Of ADC now. Okay. So ADC means analog to digital converter. So what is meant by ADC? So we'll discuss in this class. Okay. So here we'll discuss what is ADC and how you are going to convert the analog signal into digital signal, and how you are going to find out the accuracy of your ADC and some of the example of ADC. Okay. So first of all, so we'll discuss some signal types. Okay, here we'll have the two types of signal, basically analog signal and the digital signal. So analog signal means what? It is an analog quantity. So analog quantity means the signal can vary with respect to the time continuously. Okay, so it cannot fixed and it can vary so continuously with respect to the time between its minimum value and the maximum value. Okay, for let's say for example, so we have the sine wave signal. So sine wave is the example for the continuous signal or analog signal. So it has the value between 0 to pi. Okay, basically we are mentioned with the 0, pi, 2 pi, right? So with respect to the time. Okay, so between 0 to pi, so it will vary continuously, right? So this value or cannot be fixed, or these values are cannot be discrete in format. So that's why we are saying that this signal as an analog signal. Okay, so basically analog signal is used to vary continuously with respect to the time. Okay, so for example, analog signal, you can say the speedometer needles. Okay, so the speedometer needles will vary according to the speed of your vehicles, right? So or basically the speed of your motor. So like that, so you can use the analog signals. And radio volumes as a function of knob movement. So when you are moving the knobs, so the particular signal will be changed. Okay, so these are example for the analog signals. Okay, so now let's see about the digital signal. So basically square wave is defined as an discrete signal or digital signal. So why we are calling these waves or digital signal means, so this kind of signal will have only two types of values. So basically high level logic and low level logic, basically 0 and 1. Okay, so this kind of signal you can also say that binary signals. So binary will have only two states, 0 or 1. So either we can say that 0 is nothing but on and 0 is nothing but off. Okay, so then why we require digital signal rather than the analog signal means, so there are few functionalities are there. Okay, so we can easily process digital data. Okay, you can easily store the digital data, so you can consume the less memory capacity. Okay, you can store this type of data we using minimal stick of the memory states. Okay, or memory size. Okay, so as compared to the analog quantity, because the analog quantities are continuously varying, or these are the most high volume contents. Okay, as compared to the digital signal. So that's why we require a digital signal. And the electronic devices like your intelligent devices like microprocessor and the microcontroller, so they will process this digital data easily, and for processing we require a less time. So that's because of it's having only two levels, 0 or 1, so you can easily process the data and we can easily store the data into the memory. So that's why we require a digital signal rather than the analog signal. Okay, so now, so what is ADC? So ADC is a analog to digital converter. Then what is analog to digital converter then? So we can say that in the two, we can define in the two ways. Okay, the first one, the normal definition of analog to digital converter is, so this is the converter, or it is the process of converting analog signal or continuous signal into the digital signal. In the terms of microprocessor, or in terms of the communication, or microprocessor, microcontroller, so then we can say that, so ADC is nothing but the small piece of hardware, so that is built in every microcontroller. Okay, so that is the definition for the analog to digital converter. Okay, so we can using ADC converter, we can measure any environment related information. Okay, so we can also connect the sensors. So we can, using sensors we can measure the environment like temperature sensor or weather monitoring, all these things. Okay, so now, so then what is basically analog signals? So analog signals, so these are the continuous in the format. So we can these values can be varies continuously with respect to the time. Okay, so then discrete means how we are going to get the discrete. So this is the continuous wave. Okay, you can see here this is the continuous wave. So then how you are going to convert this continuous wave into discrete format. So this is the discrete wave. Okay, so in the discrete wave, so we'll get the only finite values. Okay, rather than the continuous values. Okay, so then how you are going to convert that the analog signal, continuous signal, into the discrete format. Okay, so this is the ADC conversion process. Okay, so we have two main steps. So first one is sample and holding circuit, and second one is the quantization, and third one you can say that encoding. Okay, sampling and holding process, quantization and encoding process. So now I will show you how we are going to convert the here. So we are going to convert this continuous time signal into the discrete format. Discrete format means we are getting the samples. Okay. So just your sample and hold circuit will contain only simple switch. Okay. So then here, and after that we'll have some capacitor at the output stage. Okay. This is the capacitor and this is the push button. So let's say that, or this is the switch, you can say that. Okay, so here in the input stage we are going to apply apply and continuous time signal. Okay, this is the analog signal, and here so we'll get the discrete format. Okay, like just say we are getting the samples. Okay, or like this, so we'll get particular samples like this. So these are the samples. So how we are going to get these samples then? So using this switch and the capacitor. Okay. So sampling is nothing but basically, okay. So sampling is basically, it is the process of, so sampling is the process of converting continuous time signal into digital, okay, or discrete. So that is the sampling process. I can say that sampling or sampling process. So it will convert this continuous time signal into the discrete format. So how it will going to convert? So using this simple circuitry. Okay, so it will contain simple switch and the capacitor. So how we are going to get it? So just it will open and close. Okay, so when it is open, so there is a gap between the one sample between the another sample. When it is closed, so it will pass the information. When it is open, it will stop the information. So this is the simple mechanism. Okay, so then, so how you are going to control this switch, okay, for turning on and turning off, or closing and opening? So this is based on some theorem. So we'll have the name called Nyquist theorem, okay, or Nyquist rate. So this will close and it will open based on the Nyquist rate. So let's say here, so in the 2MP camera, so we have the 2 megapixels. Okay, so let's say, so I will take the some resolution here. So the pixel will be arranged like this, right? So here, so we have the number of rows and the number of columns. Okay, so let's say, in 2MP camera, so the pixels are arranged like this. Okay, so just assume that. Okay, so we have the minimal number of pixels, so that has to detect an object, particular object, right? Okay, just say that. Okay, okay, let's say, so this is the 2MP camera. These are the pixels arranged in the 2MP. Okay, So that means, so each pixel, so these are called as an pixels here, okay. So these corners, okay, these corners are called as an pixels, okay. These are the pixels. So what the pixel will do in the camera, so that will hold an object, okay. ನೀವು ಒಂದು ಇಮೇಜ್ ನೀವು ಏನಾದರೂ ಕ್ಲಿಕ್ ಮಾಡಿದ್ರೆ ಅಂದ್ರೆ ಏನಾಗುತ್ತೆ, ಆ ಇಮೇಜ್ ಅಲ್ಲಿರೋ ಆಬ್ಜೆಕ್ಟ್ ನ ಅದೇನ್ ಮಾಡುತ್ತೆ, ಹೋಲ್ಡ್ ಮಾಡುತ್ತೆ, ಓಕೆ. ಸೊ ದಟ್ ಆರ್ ಕಾಲ್ಡ್ ಆಸ್ ಅನ್ ಪಿಕ್ಸೆಲ್. ಸೊ ಇಲ್ಲೆಲ್ಲ ಇರೋದೇನಾಗುತ್ತೆ, ನಿಮಗೆ ಇಮೇಜಸ್ ಎಲ್ಲ ಹೋಲ್ಡ್ ಆಗ್ತಾ ಬರುತ್ತೆ, ಓಕೆ. ಸೊ ಇನ್ ಬಿಟ್ವೀನ್, ಸೊ ಇಲ್ಲಿ ಗ್ಯಾಪ್ ಇರೋದೇನಾಗುತ್ತೆ, ದೀಸ್ ಆರ್ ನಾಟ್ ಪಾಯಿಂಟೆಡ್ ಬೈ ದ ಎನಿ ಪಿಕ್ಸೆಲ್. ಸೊ ದೆನ್ ಸೊ ಅದಕ್ಕೆ ನಿಮಗೆ ಇಮೇಜ್ ಏನಾಗುತ್ತೆ, ಬ್ಲರ್ರಿ ಜಾಸ್ತಿ ಕಾಣಿಸುತ್ತೆ. ವೆನ್ ಯು ಆರ್ ಜೂಮಿಂಗ್ ದ ಯುವರ್ ಇಮೇಜ್, ಸೊ ಯು ಆರ್ ಗೆಟಿಂಗ್ ದ ಬ್ಲರ್ರಿ ಇಮೇಜ್. ಸೊ ವೈ ಇಟ್ ವಿಲ್ ಹ್ಯಾಪನ್, ಸೊ ಬಿಕಾಸ್ ಆಫ್ ದ ಪಿಕ್ಸೆಲ್ಸ್, ಓಕೆ. ಸೊ ಆ ಆಬ್ಜೆಕ್ಟ್ ಅಲ್ಲಿ ಏನಿರಲ್ಲ, ಪಿಕ್ಸೆಲ್ ಪ್ರೆಸೆಂಟ್ ಇರಲ್ಲ. ಸೊ ದಟ್ ಈಸ್ ನಾಟ್ ಏಬಲ್ ಟು ಹೋಲ್ಡ್ ದಟ್ ಆಬ್ಜೆಕ್ಟ್. ಅದಕ್ಕೋಸ್ಕರ ನಿಮ್ಗೆ ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ ಬ್ಲರ್ರಿ ಇಮೇಜ್ ಬರುತ್ತೆ. So what will happen in the 16 MP then? So this is also similar to the 2 MP, but we are increasing the number of pixels, okay. So here, so just I will copy over here, okay. So now so in the what will happen in the 16 MP means, so just they are simply increasing the number of pixels, okay, like this. So just I will take one more, okay. So like that they will increase the number of pixels to locate every object, okay. So then we won't get any lossy information, okay. So here, so let's say, so this is the 16 MP as compared to the 2 MP megapixel camera. So we'll get the more clarity. So how we are going to get more clarity? So because of this arrangement in the pixels or camera, okay. These arrangement pixels are in the camera. So you can see here, as compared to the 2 MP, okay. So we'll get the more clarity because so we have the more number of pixels. So these pixels will hold the object in the image, okay. So then we won't get a blurry image as compared to the 2 MP camera. So like that. So this is the resolution, right? So this is the resolution will depend by the camera. So like that, here also will define the accuracy based on the bit depth of your quantization levels, okay. So these quantization levels will be increased by the bit of ADC, okay. Obviously if the bit of ADC is increased, so then we will get a more accuracy, okay. So that is the basic conclusion, okay. So now, so after that, so we have two types of errors here, okay. So there may be a chance of getting error while converting the ADC. So what are those? So aliasing and the guard band. So basically we have the aliasing effect and the guard band effect. So another one we have the quantization error or resolution error. So that these quantization errors will occur in the resolution part, okay. So then what is aliasing? So here the aliasing effect will occur when your sampling frequency is less than or equal to 2 FM, okay. So here the input signal is changing much faster than the sampling rate is nothing but what your sampling frequency is lower than the maximum frequency. So then we'll get an aliasing effect, okay. That is the aliasing effect. So when this frequency is, so that is nothing but sampling frequency is less than or equal to less than only. So the sampling frequency is less than 2 times of your FM signal or basic original signal. So then we'll get an aliasing effect. So we have another effect called guard band effect. So guard band effect means when you are choosing a higher sampling rate, okay, as compared to the fs greater than or equal to 2 FM. So we are taking more higher value than the 2 FM, okay. So then again we will get an effect called guard band effect, okay. So there will be two types. When you are taking the sampling frequency lower than the maximum frequency, then we have the effect called aliasing effect. When you are taking the much more higher rate of the sampling frequency as compared to the maximum frequency, so then we will get a guard band effect, okay. So then we have the another one is called quantization error. So this quantization error will depend upon the bit depth again, okay. So when the bit depth is the difference between the bit depth is very high, so then we'll get a quantization error because of the rounding of the samples. So we'll get this kind of errors, okay. So So that's why, so you have to take the more bit of ADC for accuracy or for converting the more accuracy. Okay. So this error will be the depending upon the sampling or resolution. Okay, basically resolution. So now we'll come up with an ADC application. So where we can find out the application. So as I told earlier, so in your mobile phones. Okay. So while transmitting voice information over the communication channels, so then we require an ADC conversation. So for converting analog to digital conversation in the mobile phones, we'll use the microphones. The microphones will convert this speech process into, or speech signal into electric signal. Okay. So like that, so we have the strain gauge, so and we have thermocouple, and we have the digital multimeter. So based on the unlock quantity, so that will give the digital information. Okay. So these are the some of the application of the ADCs where we can find the ADC applications. Okay. So then, so we have the types of ADCs. Here I will list out the only types of ADCs. Okay. So I won't explain all these types of ADCs. Okay. Just see here, these are the different kinds of ADCs. Successive approximation ADC and flash type of ADC and dual slope and delta sigma. So why we are differentiating the ADCs? So because the some of the application will require the faster response, some of the application will require the slower response. Okay. So some of the application will have the higher resolution, so need a higher resolution. Some of the application will need not higher resolution or medium resolution. So based on your application or based on your operation, so we can choose the particular type of ADCs. Okay. Here, so the fast type of ADCs. So if you say that I want a fast response or I want fast conversation process, so then we can go for the flash type of ADCs. Okay. So then you can also choose so I don't want any fast response. So even though slow response, I want to achieve the more accuracy. So then we can go for the successive approximation. So like that, if you want slower operation and the medium cost and so we can also get the high resolution. So then go for the dual slope ADC converter. So like that. So based on your operation or based on your application needs, so you can choose the particular type of ADCs. Okay. Let's see the difference here. So you can see here the dual slope type of ADC will have the relatively slow speed. Okay. And it will be find out in the medium cost. Okay. So what is the resolution? So the resolution means basically bit of ADC. So here we can use 12 bit or 16 bit ADC. Okay. So otherwise, if you want a very fast response, so then you can go for the flash type of ADCs. Okay. It is a relatively very high speed conversion and the cost is also high and resolution is also between the 4 bit and the 12 bit. Okay. And we have the successive approximation on the third side. Okay. So here we will get in the medium fast. Okay. So this is the medium fast converter and it has the relatively low cost as compared to these two. Okay. And what is the resolution? So we'll find out 8 bit or 16 bit up to. Okay. So then we have the another one is sigma delta. So this is the slow speed. Okay, it will the conversation process is very slow as compared to the flash type and successive approximation, and the cost is also low, and we can see the resolution is higher resolution. So okay, so this is the 12 bit to 24 bit. So as compared to the all these three types of ADCs, we will get more resolution here. Okay, in the sigma delta type of ADC. So as I said earlier, so if you want more accuracy but I don't care about the speed, okay, so when we are looking forward only accuracy, so then go for the sigma delta. Okay, when you are looking for the both, okay, so I want to convert I want to finish the process in the minimal stick of amount or minimal amount of time. So and then at the same time I require a high resolution, so then go for the flash type ADC. Okay, so like that. So based on the application, so you can choose the different types of ADCs. Okay, so this is all about the ADC conversion process. You guys have any doubts? So if you guys have any doubts or questions in your mind, you can ask me now. Okay. So, you guys have any doubts? So in case of LM35 sensor, okay, so it will measure the temperature in directly in the degree Celsius only. Okay, so it will measure the temperature and it will use the values in terms of degree Celsius. So that is the one of the feature. So why we are using LM35 here? Okay, so this is your LM35. Okay, so you can see here, this is the LM35 pin node diagram. The first one is VCC. Okay, so it can support up to 4 voltage to 30 voltage VDC. Okay, so we can apply it up to the 4 voltage to the 30 voltage VDC. Okay, so then the middle pin is the Vout pin. So this pin should be connected to the analog pin of the Arduino microcontroller. Okay, so then we can connect the third pin to the ground. Okay, so connect ground to ground, VCC to 5 volt, and middle pin to the any one analog pin on the Arduino microcontroller. Okay, so and another thing is here, so it will measure the temperature in terms of degree Celsius only, but it will won't provide the particular value for the particular degree Celsius. So like that. So here, so just assume that if the room temperature as 1 degree Celsius, then your temperature sensor won't use the value as 1 directly. So it will use 10 millivolt instead. Okay. So in the per degree Celsius, it will use the 10 millivolt. Okay. So keep this point in your mind. So because while coding, so we have to take this feature. Okay. So we have to modify this value. Okay. So for per degree Celsius, it will use the 10 millivolt. Okay. So then, so we can also use the different kinds of sensors also. Okay. So here why we are using LM35? So already told that. So it will measure the temperature in terms of degree Celsius only. Okay. So and this temperature sensor is more accurate than your thermistor. So why? Because so while using thermistor, we have to build some amplifier circuit. So externally, okay. So we have to build the amplifying circuit externally. So that's why. So that is the inaccurate as compared to the this LM35 sensors or any other temperature sensors. Okay. So that's why. So we are using the LM35, and it will measure the temperature in degree Celsius directly. So that is the main important. So then. So what is the formula? Basic formula you are able to convert this on temperature into the normal temperature. So that is nothing but the working temperature. Okay. So then how we are going to convert? So this is the steps, basic formula. Okay. So first we have to take the analog input voltage and we have to divide by the step size. So what is the step size here? So we have the 10-bit ADC. So we'll get 1024 level. So that is nothing but the step size. So analog input voltage. So analog input voltage means so we are applying voltage, the applied voltage basically. Okay. So then we'll get an output voltage. So here the reference voltage is 5 volt. So because we are applying 5 voltage to the temperature sensor. So that purpose the V reference voltage is 5 volt. Okay. So what it means basically, so 10-bit ADC means, so we are dividing total 0 to 5 voltage into the 1024 steps. Okay. So here basically 0 is nothing but 0 voltage, 1024 step is nothing but 5 voltage. So like that. So what about 2.5 voltage? So that is the half of your steps. So then we'll get in a 512. So like that. So based on the input voltage, we'll get the particular digital value. Okay. We will see this result. Okay. So after that, some of the other temperatures are also available in the market. We can also use this temperature. Okay. In the IoT part, so I will use DST11 temperature and humidity sensor. Okay. So DST11 is the sensor. So using only one sensor, we can measure two operations. So we can also measure temperature and the humidity. Okay. So we can also use the thermistor 10K. So this is basically used for the body temperature. Okay. So these are the different kinds of sensors are available in the market. Okay. The DST11 sensor is the most widely used sensor, temperature sensor. Okay. So while using IoT applications, so we'll use this kind of sensor. Okay. For now, so we'll use the LM35. So just we are going to connect this LM35 into our Arduino microcontroller. So then we'll read the temperature and we'll display on the LCD display. So this is the basic mini project. Okay. So you can also take this as a mini project. Okay. So for measuring the room temperature and alerting the user. So when the temperature is reaches the threshold value, so we'll give the some alert sound. Okay. So now I'll move on to the LinkerCAD. Okay. So just wait a second. So in the previous class we already interfaced LCD, right? So I'll go for that circuit. Okay, just take Arduino microcontroller board and take LM35 sensor. Okay, so this is LM35 sensor. The first pin is VCC. We already seen the pin out of LM35. So this is the VCC and middle pin is the output pin and the last pin is the ground pin. So just I will connect this pin to ground. Okay, oh sorry, this pin to VCC. And oh sorry, oh VCC, right? So I'll make it as red. Okay, so then so last pin to ground. So next middle pin to the unlock pin. So I'll connect it to A0 pin. Okay. So don't connect this pin to the any one of the digital pin because digital pin won't measure any unlock quantity. Okay. Okay. So this is the connection diagram or interfacing diagram of LM35. Okay. So after that we have to take the LCD display. Okay, so we already seen the connection diagram of the LCD display in the yesterday classes or previous classes. Okay, so just connect LCD and display this information on the LCD display. Okay, so just I will move forward to the LinkerCAD website. Okay, here so we already seen the, so just I will remove the temperature sensor. Okay, so this is the basic circuit diagram for LCD controlling operation. Okay, so here so all of you guys, so I will show you the scrolling LCD display program. Okay, this is the scrolling LCD display program. Okay, so without using any inbuilt function, so you can also use the inbuilt function. Okay, so as your interest, so you can use the inbuilt function also. Either if you don't want to use any inbuilt functions, so if you want to improve your logical skill, so then you can go for the for loop or without any inbuilt function, so you can create our own logic. Okay, so this is your program for scrolling an LCD display. Okay, just I will show the demonstration. Okay, I have error here. So here LCD. Okay. LCD and here also LCD and LCD clear. So you can see here, 1 minute. So here J comma high, and just give the delay. So you can see here it is scrolling. Okay, so like that we can use the scroll LCD display. Okay, so just I'll take delay as 100. Okay, you can see here, so it is scrolling. Okay, so this is the scrolling from left to right. So either we can also do the right to left also. Okay, so now, so just I will interface LM35. Okay, so just search temperature sensor. Okay, so then we will find out the LM35 here. So just I will connect here. Okay, the first pin is VCC. Okay, you can see here the first pin is already coupled with the VCC line. Okay, here it is connected. Okay, so and the last pin is, okay, the middle pin is the output pin. This should be connected to the unlock pin. Okay, I will connect this to unlock pin. And last pin is the ground pin. Connect last pin to ground. Okay, so that's all, guys. So now we'll move forward to the coding part. Okay, so just open Arduino IDE. Okay, so now I will so what is the first step? You can see here, so LM35 is the input device, so that is hooked with the A0 pin. Okay, so after that we already know the LCD operation. Okay, just read the information and convert into the actual degree Celsius value and display it on the LCD display. So this is my requirement. Okay, so for that purpose, what is the first step? Okay, first we have to make that particular A0 pin as an input, so that's why I will take pin mode A0 comma input. Okay, after that, so just I will read the information. Okay, so let's say, so int, okay, int ADC val. Okay, I will take a variable called as an ADC val. Okay, so after that I will reading the information. So we are going to read the particular information or status of the particular pin using digital read. So using digital read means we'll get only two values, 0 or 1. So here we have to read the unlock quantity, right? So that purpose I will use unlock read. So unlock read means it will use 1 0 2 3 values. Okay, 0 to 1 0 2 3 values. So and here we are connected with the A0 pin mentioned here. And then the first of all, so what is the reference voltage? We have to convert our unlock signal into the reference voltage. So where you are applying 5 reference voltage. So that's why we have to multiply that reference voltage into the ADC value. So then we will get an accurate value. Okay. So that purpose I will take again int ADC update. Okay. So this is the update value. Okay. So we are going to update that. So here we will get an ADC raw ADC value. So we have to convert into the applied voltage. So what is the applied voltage? That is 5 volt. Okay. So now we will get the values in the form of degree Celsius, but it will give 10 millivolt per degree Celsius. Okay. So let's say, So if the room temperature is 1 degree Celsius, so then it will give the 10 millivolt, okay, or 10 value. So if the degree Celsius is 2, so then it will give to 20. Okay, if the degree Celsius is 10, so then it will give the 100. So now I have to convert this into the particular format. So like that. So here instead of 10, I have to display 1. Okay, instead of 20, I have to display 2. Instead of 100, I have to display 10. Okay, so then we'll get an accurate value. So then how you are going to do that? So if I want to get the value as it is, so that is nothing but in terms of degree Celsius, like 1 degree Celsius, 2 degree Celsius, or 10 or 15, like that. So now tell me how you are going to convert this value into the particular degree Celsius. Anybody? Okay. 0, 1 and LCD dot print sensor interfacing, okay, or measuring room temperature. Another new display ಮಾಡಬಹುದು. Okay, so just I will take that. So measuring room temperature. After that, just I will give the delay for waiting. Okay, 2 seconds. Okay. So after that, so before printing anything, so remember this point. Before printing anything, so just we have to clear the LCD display. So that's why I will take LCD dot clear. Okay, and after that, just I will display. Instead of displaying only numbers, I will display the temperature value. Okay. So first I will display this one. Okay, after that I will modify. Okay, just I will copy this code. Okay, so what I did here, so just including liquid crystals and assigning the pin numbers and initializing LCD display, making A0 pin as an input, and you are displaying the previous statement called, okay, this is the default statement called measuring room temperature. Okay, so after that in the while loop section, so we are reading the value of temperature and we are updating that value into the LCD display. Okay, so just I will take this value of program and will paste it here. Okay, then I will run the code. So we will get an error here. So just to take temperature. Just a minute. LCD print LCD print temp. Okay. After that I will display the value, and after the value I will display LCD dot print the degree Celsius like this. Okay, just I will use delay as 500. Then simulate. So here we are getting 76. Okay, so based on the value, so we can increase or decrease the value. Okay, so in your case, okay, in the hardware part, so we'll get the current room temperature. Okay, so here I will set to the 76. Okay, you can see vary here, so it is varying, right? So the what is the range of your LM35? So it is the range between 10 to 179 or 180, you can say that. Okay, so 10, the minimum is 10. Okay, 10 degrees Celsius. Okay, so like that, so you can measure the room temperature. So this is the interfacing diagram of LM35 and this is the code. So this is actually temperature measurement. Here just I will take Arduino board and breadboard and potentiometer. Okay. So now I will apply VCC and ground. So VCC to VCC and I will connect VCC to VCC. Next ground to ground. And another pin to the ground. Okay, potentiometer ಗೆ ಒಂದು ಪಿನ್ VCC and another pin ground ಮಾಡಿದೀನಿ and middle pin varying pin ಏನು ಮಾಡ್ತಿದ್ದೀನಿ ಅಂದ್ರೆ so unlock pin ಗೆ ಕನೆಕ್ಟ್ ಮಾಡ್ತಿದ್ದೀನಿ. Okay, just convert. Okay, just I will connect this pin to unlock pin. Okay, this is the conversion. So this is the simple conversion of analog to digital. Okay, so now let us see whether it will give the correct result or not. So here, so that purpose, so just I will use serial monitor in the code. Okay, so I will explain what is meant by serial monitor in the next upcoming classes. Okay, so for that purpose, so I will take the port, so that is nothing but A0 pin as an input. Okay, so after that I will read the information. Okay, just I will take int ADC. Okay, int ADC and I will read unlog read. I will use unlog read function and A0 and just I will display on the serial monitor. Okay, so just serial dot begin 9600. I will explain in the later. Okay, so here and I will print this value serial dot print. This is similar to the LCD display. Okay, but it will use word communication. Serial. Okay, and the ADC value. Okay, ADC value.